Okay, section 3.1 deals with quadratic functions. Before we get into talking specifically about quadratics, though, I just want to review a couple common functions that we've discussed before. First one being the constant function, the f of x equal a. If we plug in a value for a, we'd have something like f of x equals 3. We should know that the graph of that would just be a horizontal line with a y-intercept of 3. So it looks something like that. And the degree of a constant function will always be 0. For the next function, f of x equals ax plus b, that is a linear function. Again, if I go to my numerical example here, plugging in values for a and b, maybe I have something like 3x plus 2. So the graph of that, we'd have a y-intercept of 2, a slope of 3, so maybe it looks something like that. The degree of a linear function will be 1 because the exponent of that x is 1. And then finally, for the quadratic function, the last one that we have listed here, we plug in values for a, b, and c, we'd be looking at something like f of x equals 3x squared plus 2x minus 2. Graphs of a quadratic will have that U shape, as we have discovered in the three activity we've been doing. The degree of the quadratic, every quadratic will be 2 because the highest exponent in the function is 2. Moving on to the next slide, we have definition of a polynomial function, and this looks extremely complicated, but I do have some examples down here that are examples of polynomials that follow the format that are in this definition, and they should help make things a little bit simpler for you guys. So as we look at these two examples, just reviewing some vocabulary, again, the degree of this particular polynomial would be 2, the leading coefficient would be 2, and the constant would be 1. All right. For the next one, the degree, the highest exponent is 4. The leading coefficient is 9. And our constant term is equal to -1. Okay. From there, we can kind of backtrack to this. So when we're looking at the definition, the degree will be the highest exponent. In this case, the degree would be n. You can see we're going n minus 1, etc. From that point forward. So those would all be lower than n. A sub n and a sub n minus 1, a sub 2, a sub 1, those are all values that are in front of the variable, so those are going to be coefficients. And then a sub 0 is a constant. Right, this value here, no variable in front of it, so that would be the constant term. We'll utilize that vocabulary throughout the course of Chapter 3, so we just wanted to run that by you so you're comfortable with it when we get there to using it. All right. So the next part that we're going to look at is how to graph quadratics. All right, we've done this a lot in Chapter 2, but we're going to revisit it here so we can be very specific with the graphs and get at least 5 points on each. So this graph here, 1/2 x squared, we should know that it will have a vertex at 0, 0, so this will be my values of x, values of y. We always have the option to plug in values for x and then getting an output for y. But with quadratics, for two examples here, we are going to take a little bit of a shortcut. All right, and we're going to look at it as how far away we're going to move to the right and left of the vertex. All right, and then what we will do is square the amount that we move to the right and left, and then multiply it by our value of a. In this case, our value of a is 1/2. So if I move 1 unit, if I start here at 0, 0, and I move 1 unit to the right, and square that, 1 squared is 1, and then I multiply that by 1/2, 1 times 1/2 would be 1/2. So I would have a point at 1 and 1/2. If I move to the left, -1, or move to the left 1 unit, -1 squared is 1 times 1/2 would be 1/2. So I'd be here at -1, 1/2. If I start at the vertex once again, and move to the right 2 units. 2 squared is 4. and 4 times our value of A, 4 times a half would be 2. So I would be here, I'd move up 1, 2 units. So I'd have a point at 2, 2. And then it'll be the same when I move to the left 2 units. Negative 2 squared is 4 times a half would be 2. So that would put me at negative 2. 2. And we plot those points. We can continue with that and find additional points, but like I said, we're just going to be looking for 5 points on the majority of the quadratics that we use this method. We look at the next graph. This one is written in our vertex form. All right, based on the x plus 2, I would know that I would move 2 units to the left, and the minus 8 would move me 8 units down. So I'm going to be at negative 2, negative 8 on the graph. Okay. The value of A in this case is 2. So that's going to stretch this graph vertically. If I start at my vertex at negative 2, negative 8, and I move 1 unit to the right, 1 squared is 1, times our value of A, which is 2, is 2. So we go 1 to the right and then up 1, 2 units. So I would be at negative 1, negative 6. If I move to the left 1 unit, negative 1 squared is 1, times 2 would be 2. So I would go to the left 1 and then up 1, 2 units as well. All right. From there, I can fill that in real quick. There would be a negative 3, negative 6. And then if I start at the vertex and I move 2 units to the right, so 1, 2, 2 squared is 4 times 2 would be 8. So I would go up 1, 2, 3, 4, 5, 6, 7, 8 units. And it would be the same if I move to the left 2 units. So 1, 2, negative 2 squared is 4, times 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. And we can plot those. All right, so filling in those coordinates really quick, we have 0, 0, and negative 4. Okay. The final slide that we'll look at for this portion, this one is written in intercept form. The great thing about intercept form is we can easily identify the x-intercepts. If we set the x plus 1, if we set this function equal to 0, set x plus 1 equal to 0, that would give us an x-intercept at negative 1, okay, so the opposite of what we have in there, and an x-intercept of positive 4, okay? So we know that those points are on the graph. We have negative 1, 0, and 4, 0. I'm only going to find 3 points on this graph. The other key one that I really need is the vertex. All right, so if I'm looking for the vertex of this graph, the nice thing is when you have the intercepts and you have a graph that crosses the x-axis twice, the intercepts will be, or I'm sorry, the vertex will be halfway between the intercepts. So we need to find the point that is halfway between negative 1 and 4. So to do that, we can find the midpoint. So the x-coordinate of the midpoint will be negative 1 plus 4 divided by 2. So if we do that, that will give us 3 over 2, or 1.5. So the x-coordinate of the vertex is 1.5. To find the y-coordinate of the vertex, we are going to plug 1.5 into our function. All right, so we'll have y equals, and just take that 1.5 and plug it in here and here. So that would be negative, and then 1.5 plus 1, and 1.5 minus 4. And if you put that into your calculator, we're going to get 6.25. So we'd have the point 1.5 and 6.25, which would be approximately here. And then we can connect those dots for our graph. Okay? That is the end of this one. You can continue the flips with the next video.